Hello, everyone. Thank you for coming. My name is Yongseon Lee, and I am a co-founder and the head of infrastructure at VESSL AI. As you can see, the title of this presentation is AI and MLOps infrastructure for enterprise-grade LLMs. So today, we'll discuss the strategies for optimizing LLMs in an enterprise setting, as well as how to use computing and human resources efficiently. VESSL AI is a startup established in April 2020, focusing on creating a comprehensive end-to-end MLOps platform. After a year and a half later, we successfully raised $4.4 million in a pre-Series A funding round. Following this achievement, we were selected to participate in the Samsung C-Lab Outside Acceleration Program. I can see the script here. Yeah, sorry. Yeah, here's what we will cover today. First, I'll explain what self-hosting LLM means and why it's beneficial and why you would want to do it. Next, I'll discuss the considerations and challenges you should be aware of when self-hosting LLMs and how to overcome them. Finally, I'll describe how using our MLOps product VESSL can benefit you when operating LLMs. So let's start by discussing the concept of self-hosting LLMs. What you're seeing now are the titles of articles related to LLMs. The first title suggests that it will revolutionize the economy, and other articles state its impact on the legal, manufacturing, and healthcare sectors. If you look at the last one, there's an article that says ChatGPT identified the cause of chronic pain that 17 doctors couldn't find. AI has already started to dramatically change the world, and at the center of this transformation are large language models. In this article written in April, as the title suggests, it raises the question of whether a single large model can solve all problems. The article concludes that companies will both utilize massive APIs like GPT-4 and also create their own custom LLMs for specific needs. Even if large models perform exceptionally well across various situations, their operational costs are substantial. So it suggests that smaller, cost-effective models optimized for specific scenarios will continue to be used. I share this view. At the end of the day, it's crucial for companies to have the capability to develop their own large language models that are precisely tailored to address the unique challenges they face. At present, there are several open source language models such as Llama2, Cloud, MPT, Falcon, and Vicuña that offer performance levels comparable to GPT 3.5 and can be trained from the ground up for practical applications. The image provides an overview of the multitude of language models developed to date, illustrating that it's only recently we've started to see truly reliable AI solutions emerge. These open source LLMs hold distinct advantages over their commercial counterparts in terms of privacy, control, and cost efficiency. Utilizing commercial LLM APIs involves transmitting data to external servers. The peril lies in the potential for sensitive information to not only be learned by the model, but also become broadly accessible with no easy means for deletion. This concern has led to a number of countries and corporations banning the use of services like ChatGPT. On the cost front, as previously discussed, highly specialized AIs often don't require an enormous size to efficiently tackle the specific problems. For instance, a model with about 7 billion parameters could be more than adequate. To put this into perspective, you could summarize Wikipedia articles at less than 1% of the cost of employing a service like GPT-4. Furthermore, taking the reins of your own LLM offers greater control over not just the training data, but also key factors such as introspection, explainability, and portability. This is along the same lines. To create a more competitive AI, differentiated data and strategies are essential. When using external LLM APIs, our service could be affected if the external service goes down. Even with OpenAI, which is currently the largest LLM API provider, the situation is not 100% reliable. If a company operates its own LLM, it can respond more quickly in case of failure and operate more stably overall. For many use cases, 1 to 7 billion parameter models are sufficient. The x-axis of this graph represents the amount of data used for model training, while y-axis indicates the training loss, which decreases as the model is trained further. The loss value reflects the level of error in the model based on what it has learned so far. So the graph demonstrates that even models with fewer parameters can catch up to larger models if the training volume is increased. Take the company Biomed LLM as an example. They trained a 3 billion parameter model using medical-related publications from PubMed and achieved superior results on the USMLE benchmark, even outperforming a 120 billion parameter model. This shows that AI training specialized in a particular field can yield excellent results even with a model size between 3 to 7 billion parameters. Conversely, if there's a need for a custom pre-trained model, you might require a more substantial LLM around the scale of 30 billion parameters. To put this in financial terms, training a model of GPT-3's caliber would entail an estimated cost of around $500,000. As a case in point, let's consider Iruda, an effective AI chatbot service in South Korea. Launched just last October, the chatbot has already amassed 2 million downloads and 900 million accumulated messages. Leveraging the technology that powers Iruda, the company is now engaging in a business that creates chatbots for other enterprises. By fine-tuning small LLMs, which are trained in a mere 3 months, they are able to craft a variety of AI characters. The company has compelling reasons for running its own LLM. First, their vision for a chatbot extends beyond the mere information disseminator like Jarvis. They aim for emotionally resonant interactions customized to Korean sensibilities. To achieve this, tailored training is imperative. The in-house operation also provides the latitude to innovate additional features such as proactive conversations and image recognition in chats. Given that AI specializes in emotional intelligence, there's a high likelihood of users sharing their sensitive personal details. This necessitates strict security measures to prevent data leakage. And operating cost and stability also are their considerations. Okay, thus far, I've outlined the advantages of self-hosting a large language model. However, managing an LLM in-house is no trivial task. In the following section, I will delve into the various factors to consider and the potential challenges that may arise when taking this approach. So I intend to address topics such as model size, throughput, and GPU supply shortages, and high cost of GPU clouds, and the various methods of model deployment. To enhance the performance of model inference, techniques such as precision reduction, quantization, and fine-tuning with LoRa, tensor parallelism, pruning, and batch inference can be considered. Notably, VLLM, developed at UC Berkeley, is capable of serving LLMs at a rate 24 times faster than traditional transformers. Although a larger model size may enhance accuracy, it also prolongs the time required for both training and inference, thereby reducing the number of iterations. Each company must find a balance tailored to its specific needs. Moreover, there should be provisions to serve any model quickly and effortlessly. The code displayed on the right is a Llama configuration that allows for the straightforward serving of a small Llama2 model via Llama2.c. I will explain this part in detail in the following demo. The cost and reliability of GPU usage is also a critical issue. If you rely on a single cloud service, you may face a severe setback if that service becomes unable to provide GPUs. Therefore, you should be prepared to use multiple cloud services like AWS and Google Cloud and make the most of spot instances. Spot instances are about 70% cheaper than on-demand instances, but they are susceptible to stop interruptions that could hurt your work. You can mitigate this risk through proper backup and recovery automation, allowing you to use spot instances from multiple clouds and regions, especially in the current situation of GPU shortages. Even if you use secure GPUs, failing to utilize them fully can lead to significant financial losses. So you should always be able to monitor your GPU cluster and quickly terminate workloads that are only reserving GPUs without actually using them. It is also essential to have mechanisms in place for rapid recovery in case of GPU issues. How you deploy the model is also crucial. If deployed as a real-time service, user experience latency must be considered and monitoring and alerting system must be well configured. Running the model as a batch job might seem more comfortable, but if you don't properly set up automated pipelines, then it could require even more manual intervention. Alternatively, you can outsource the operation to a SaaS specialized in serving. It is convenient, but tends to more expensive. So it is more suitable for services with relatively low traffic. Additionally, how quickly you can iterate the fine-tuning process is also important. Managing data sets and checkpoints is necessary. And as shown on the right, you can speed up the iterative runs by managing execution settings by YAML. So running an LLM yourself requires consideration of many factors and is quite challenging. The larger the model size, the greater the infrastructure needed for deployment and fine-tuning. Implementing all of these things yourself would require a tremendous amount of manpower and time. So using a specialized MLOps platform could be a good idea. MLOps platforms offer the following features: hybrid GPU clusters with spot instances, and training jobs management, and the management of data sets and models, model solvings, automated pipelines, role-based access control, and programmatic runs with SDK CLI. So moving forward, I would like to introduce VESSL AI, which is one of the MLOps platforms designed for self-hosting LLMs. VESSL AI provides a range of features such as LLM Hub, VESSL Run, VESSL Serving, VESSL Pipelines, and LLM Endpoints and Fine-Tuner. LLM Hub offers a centralized platform where you can quickly and easily test various LLMs. It allows you to monitor model trends and even run training inference sample codes for models of interest. The hub features a variety of models such as Llama2, T5, MPT, and GPT-Neo-X, and also provides usage examples for serving optimizers like VLLM and Llama2.c. Through VESSL Run, you can execute any ML workload on any environment with any scale with the same interface. So you don't have to worry about anything other than writing the core code. The platform also offers cost-effective GPU options and is well equipped with the earlier mentioned features such as hybrid clusters and spot instances. Additional conveniences like YAML configuration and SDK CLI are also available. You can configure the execution environment either through the web interface as illustrated on the right, or by using the CLI. This is a simple example of YAML provided by VESSL. You can set the name and the GPU to use, which Docker image to use for running which code, and which ports to open. If you create a run with the YAML like this, with the -f option, you can view the standard output logs as well as the URL of this particular run. The details of the run are also accessible through the web UI. It also supports multi-node fine-tuning and features like hyperparameter search and model reproduction, model serving, and Jupyter notebooks as well. VESSL Serving assists in reliably delivering trained LLMs to customers, providing advanced features such as auto-scaling, monitoring dashboards, deployment strategy, load balancing, and revision control, and A/B testing. This is an example of a serving workload YAML. And this is the page for setting up load balancing and rollout strategies. VESSL AI also offers pipeline features, allowing you to easily construct pipelines with drag and drop functionality. It also provides scheduling and event triggers. By using pipelines, you can automate the training and deployment of LLMs. LLM endpoints and fine-tuner offer features specifically designed for more specialized fine-tuning and inference of LLMs and are currently in the private beta stage. That concludes our brief introduction to VESSL AI. Next, I'm going to show you a video demonstration featuring the actual operation. The demo will quickly train a baby Llama2 model and save the resulting model to model registry, and then serve it using Streamlit. So in this demo, a virtual environment with Python 3.11 is already set up, and VESSL CLI is installed. Now let's play the video. Yeah, this is the Llama2 run, and VESSL run create with the YAML. And let's click the URL of the run. And this is the detail of the run. And you can see it's using 4 A100 GPUs, and this is start command. And let's check the logs. And now it's in the initializing status. And you can also see here. And now it's running, downloading Python dependencies, and unpacking dataset called tiny stories is like 1.5 gigabytes. And it's sample of the dataset. Yeah. Now training the model. And yeah, the training is over, and this is the sample output, testing output of the model, and the model is uploaded to the model registry. So let's go to the model registry. Yeah, here's the model. It just uploaded. Yeah, this is the model file, like 40 seconds ago. And it's going to run an inference run with the YAML pasted here. And then the form on the left will be filled automatically. And then create a directory input and import the model we just uploaded here. That one. It's imported. And here is start command to run Streamlit on port 8000. And here is configured to which port to open. And now it's running in the pending status. Yeah, it's running on the AWS cluster. And it's now initializing. And then it's running now, okay. And let's click the URL of the Streamlit. Yeah, this is the Streamlit page, and this is the output from the trained model. And you can input the parameters like temperature and steps like this, and each time the model gives different outputs. Yeah, this is the end of this demo. And you can watch this video later on SDC website. In conclusion, operating your own large language models with sizes ranging from 1 to 7 billion parameters can offer various benefits to your business. So to summarize the process of custom LLM implementation, first, start from running open source LLMs, then proceed to build your own LLMs, and build a robust AI infrastructure to support them, or leverage on MLOps instead of building the infrastructure by yourself. Yeah, thank you for your attention. And if you have any questions, please send an email to contact@VESSL AI, or feel free to talk to me at the networking zone just right outside this room. And this is the very last presentation of this session, and next sessions will continue on SDC24 next year. So yeah, I hope